In this video, we are going to look at trigonometry. We are going to get as far as angle of elevation, but we will not do the sine rule and the cosine rule. That will be left for another video. And we also will not solve any CXE question because we would need to know the sine rule and the cosine rule. So first of all, types of triangles. I didn't put all the types of triangle here, just the important ones. We have the right angle triangle. We have the equilateral triangle, all sides are equal. We have the isosceles triangle, the base angles are equal. This angle at the top, and then you have the base angles are equal, these two lengths are equal. All sides are equal for the equilateral triangle. Then we have the scalene triangle where all sides are different in length and all angles are different in size. So over here we do a topic that many persons overlook, but I did see a question in the CXE paper, but it was years ago. Similar triangles. Triangles are similar when they have the same angle. If the angles are different, then the triangle is not similar. So biggest question is, are these two triangles similar? We have this angle here, that one is similar to that one. This one we don't know what it is and we don't know what this one is. So if the angle in the triangle add up to 180, then the 60 plus the 35 will give you 95. You subtract from 180, you'll get 85. And if the angle in the triangle add up to 180, which it does, when you add these two, you'll get 120. Right, and you subtract 120 from 180 and you'll get 60. So these triangles are similar triangles because they have the same angle. So are these triangles similar triangle? Yes, they are. How do we know that? They are connected by this line, and in one of the videos we did, vertically opposite angles are equal. This angle is equal to that angle there, so we know it's equal. So, but if we were given the lengths of all the sides of one triangle that is similar to the other, how do we find this length here? There are two ways of doing it. We can find something you call a scale factor. Scale factor will tell you by what size or by what multiple this triangle is bigger than that one. And we get a scale factor by dividing sides that are in the same position, or yes, we can see that sides that are in the same position. 15 and 75 are the two sides that are in the same position. Why? Because they are the adjacent side. If this was the angle, these two will be the adjacent side. So if we divide 75 by 15, we'll get a scale factor K, which is equal to 5. And if you multiply 5 times 15, you'll get the 75. So this side is bigger than that side by a multiple of 5. There's also, so if we want to find what x is, we divide 40 by 5 and we'll get 8. See how that works? Because it's supposed to be, x is supposed to be, or 40 is supposed to be 5 times this x here. Same thing for y. You divide this side by 5 and you'll get what that side is. There's another way of doing it. Same way, you can use it either way, but this is a more concrete way if you want to say that, where you divide the sides. Let me section this off. So you'll have the length of the side that you're given, which is you can put the larger side above the smaller side, 75. Let me write right here. This is called LO. It's the LO divided by, this is called OQ, and the side that you want to find, which is, let's find x first. This is PQ divided by LM. So we put in the larger side of, so LM goes up first. LM divided by PQ. So you'll get 75 divided by 15 meters is equal to, LM is 40 meters divided by X. So we cross multiply, or we divide here first, so we get 5 is equal to 40 meters divided by X, and we cross multiply. X times the 5 is equal to 40 meters. Then we take over the X, the 5, and if it's connected to X by multiplication, when it goes over it becomes division. So X is equal to 8 meters. You can do the same thing. Put the larger side, the larger corresponding side, this side corresponds to that side. Put the larger corresponding side above and the smaller corresponding side beneath. For Y, that will be OM divided by OP, or you can do the other way around. Okay? So that's it for similar triangle. We go on to Pythagoras theorem. This is very, very simple. All right? To know Pythagoras theorem, you must know the statement for Pythagoras theorem. Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. What does that mean? First, you identify the hypotenuse. This is the hypotenuse. This is A. This vertex is A. The length of the side opposite it is called common A. So CB or BC is common A. This is AB, the length. So the length will be called common C. This is B. So the length will be called common B. So if we go to write Pythagoras theorem states that the square of the hypotenuse square is equal to, sum means to add. The other two sides is B square and C square. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So A square is the hypotenuse, A is the hypotenuse, so A square is equal to B square plus C square. Alright, so how do we apply Pythagoras theorem? If you're trying to find the hypotenuse, the hypotenuse is always outside of the formula, I should say. So this side is F, this side is E, and this is G. So this Pythagoras theorem states that the square of the hypotenuse F is equal to the sum of the squares. This will be G squared plus E squared. We don't know what F is. We put back the F is equal to, G is 4 centimeters squared, plus E is 3 centimeters squared. F squared is equal to, this is 16 centimeters squared over the centimeters. This is 9 centimeters squared over the centimeters. You can add those over there. So we have 25 centimeters squared. So F is equal to, we take over the square, becomes square root of 25 centimeters squared. F is equal to 5 centimeters. In this instance, you're given the hypotenuse and you're asked to find another side. Oh, I must say, when Pythagoras theorem is used. Pythagoras theorem is used only on the right angle triangle, and Pythagoras theorem is used when given the length of two sides of a right angle triangle and you're asked to find the third side. So it's the only time Pythagoras theorem is used. So we have here the hypotenuse is A, this side is B, this side is C. So A squared is equal to B squared plus C squared. A is 21 meters squared is equal to B is 14 meters. That must be squared, plus we don't know what C is. Squared. 21 squared is equal to 441 meters squared. 14 squared is equal to 196 meters squared, and C squared. So when you have this now, you have to bring over that, because we're trying to find C. meters square minus 196 meters square is equal to c square. So now 441 minus 196 is equal to 245 meters square, and that is equal to c square. So c is equal to the root of 245 meters square. C is equal to, give me 245, root of 245 is equal to 15 and 15.7. 15.7 meters. And that's Pythagoras theorem for you. When you have to find the hypotenuse, you add. When you have to find any other side, you have to subtract. Good. So we now look at the trig ratios, the trigonometrical ratios. When are the trig ratios used? What are the trig ratios? Sine, cos, and tan. When are the trig ratios used? The trig ratios are used when given the length. Well, also the trig ratios are only used on the right angle triangle as well. The trig ratios are used when given the length of one side of a right angle triangle and an angle, and you ask to find another side. Or when given the lengths of two sides of a right angle triangle and you ask to find one angle. So it always works like that. You look for whether you're given the length of one side and an angle and you ask to find another side, or when you're given two lengths of a right angle triangle and you ask to find a angle. Okay, so the trig ratios are sine, cos, and tan. First, we need to know how to identify the different side of the right angle triangle. The longer side is also called the hypotenuse, and it is always opposite the right angle. The side opposite the given angle is called the opposite side. Okay, and the other side is called the adjacent side. Sine is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. Tan is equal to opposite over adjacent. And well, this is the hypotenuse C, so there will be opposite over hypotenuse will be over A, that is sine. So how do we select which ratios to apply is the next question. So we have this question here. Forget about this. We have this question here. We're given an angle, so we know this is the opposite side. This would be the adjacent side because this is the hypotenuse. We're given an angle. We're asked to find this side, question mark, find that side. All right, that side will become on B. We're given one length, the length of one side. We're given an angle and we're asked to find another side, so we have to use the trig ratios. This is the opposite side. We are given the hypotenuse. The only ratio that has opposite and hypotenuse inside is the sine ratio. So that's how we select which ratio we use. We look for which two sides which side we're given and which side we're asked to find. So this would be sine theta is equal to opposite over hypotenuse. Sine 47 degrees is equal to the opposite side is B. B over the adjacent, the hypotenuse is A. Sine 47 is 0.731. B, we don't know what B is, so we know A is 13 centimeters. Here we cross multiply. 0.731 times 13 centimeters is equal to B. So 13 times 0.73 what am I doing here? 13 multiplies 0.731 is equal to 9.5. So B is equal to 9.5 centimeters. And that's how we calculate the other side. That's how we use the trig ratios. So on this side, all right, we will observe again. We are given an angle. This is 60. This is the opposite side, obviously. This is the OPP. And we asked to find this side. This is the longest side, which is the hypotenuse. So, tan theta, why are we using tan? We're given the opposite, and we asked to find the hypotenuse. We have to use sine. Sine theta is equal to opposite over hypotenuse. So, sine 60 degrees is equal to, opposite side is z, hypotenuse is x. So this would be z over x. Sine 60 is 0.866. This is equal to, we know z is 9.6 meters. We don't know what x is. So we have to cross multiply. X come over and multiply 0.866. That is equal to 9.6 meters. Then we take over the 0.866. So x is equal to 9.6 meters divided by 0.866. X is equal to 9.6 divided by 0.866. X is equal to 11.1 meters. And you can see that this is the longest side, so it has to be bigger than this side up here. Okay, our final question, and then we will identify what will have to be used here, and then you can use it. So I must show you, when we were finding the opposite side, we had to cross multiply and multiply. But when we're finding the hypotenuse, we have to cross multiply and then take over back, and we have to divide. So this is the other condition under which the trigonometric ratios are used when given two sides of a right angle triangle and you're asked to find a third side. So in this case, we're given the hypotenuse and we're given the opposite side. So we have to find this angle. If we were asked to find this angle, then this side would have been the opposite side. If we were asked to find this angle and we were given these two sides, then we will have to use cos because we're given the adjacent. This would have been the adjacent side. We're given the adjacent and the hypotenuse to find an angle, so we'd have to use cos. But in this case, we're asked to find this angle up here, and we're given the opposite side, so we have to use sine. Sine theta is equal to opposite over hypotenuse. Right? This is m, this is o. So we have sine theta is equal to o over m. Sine theta is equal to, O is 7.5 centimeters. M is 12 centimeters. We divide those two, 7.5 divided by 12, we get 0. Sine theta is equal to 0.625. Now to get the angle here, we take over the sine, and it becomes sine inverse 0.625. So sine inverse 0.625 is equal to 38.768. So the angle theta is equal to 38.7 or 38.68, right, degrees. So look at the bottom here. I will have to stop this video and do another video for angle of elevation and depression. The time is too much. Okay, so look at the bottom here. We have 4 triangles here, and we have to identify which ratio we have to use here. So this one, we're asked to find this side. We're given an angle, we're given a length, and we have to find this side. This side is the adjacent side. This is the hypotenuse. So the ratio that includes adjacent and hypotenuse is cos theta is equal to adjacent over hypotenuse. So you're going to solve these. Alright. In this case, in the triangle 2, we're given this side and this side, and we have to find this angle. This is the opposite side. This is the adjacent side. So the ratio that includes opposite and adjacent is tan. Tan theta is equal to opposite over adjacent. Alright, in triangle 3, we're given this side, the length of this side, this is the hypotenuse. We're given an angle and we have to find the opposite side. This is the opposite side. So we have to use sine there. Sine theta is equal to OPP over HYP. And the final one, we're given the length of this side. Oh, I didn't finish this one. We're given the length, it wasn't supposed to be this side. It's supposed to be this side as 120. Yeah, 120 kilometers. This angle was supposed to be 48. And we were supposed to find this side. So this is the opposite side. This is the adjacent side. So we have to use tan. Because we are given the opposite and an angle, and we have to find the adjacent. OPP over ADG. So that's your trig ratios. The next video, we are going to use the trig ratios to solve angle of elevation and angle of depression.